Hello everyone, I hope you are doing well. I just want to say congratulations to the 2023 Maths Method students for completing their exam too. I hope it went well to your standards. I haven't had a look at it, so I want to try it out right now. I've just got some of my students, after the exam took pictures, I put this all together and yeah. So let's just use it. Like always, guys, before I start this video, guys, if you guys want private tutoring, if you have your brothers, sisters, anyone that please, if they want method tutoring, specialist physics and chemistry, they could email me through this email right over here and I'll be there. So yeah, let's smash through this paper and see how it went. So again, guys, these are my suggested solutions. They are not 100% right. They could have one mistake or yeah. So let's go. Question 1. The amplitude A and the period P of the function f of x, this is what? So your amplitude is a half, not negative. Amplitude is a half. So we can surely take these ones out. And your period is just 2 pi over this constant over here, which is 3. So choose E as your answer. Next question. For the parabola with the equation this, where A and B and C are all elements of all reals, the equation of the axis of symmetry is what? So if you don't know, if I'm not mistaken, the axis of symmetry is, this is the formula, negative B over 2A. And yeah, so your B value here is 2b, and your 2 times your a value, which is just a, which is just negative b over a, which is a. Let's just 100% make sure that's right. So what I'm going to do is go on my CAS and just define f of x as a times x squared plus 2b times x plus c. So, and I'm going to just solve for f of x equals 0, comma x, and I know the axis of symmetry is between them, so I'm going to add both of these together and times it by half, which is negative b over 2a. So negative b over a. So perfect. Let's move on to the next question. Question 3. Two functions p and q are continuous over their domains, which are this and that, respectively. The domain on this of the sum of the function is what? Okay, if you have two functions, put together or added together, their domains is pretty much the intersections of the two domains. So what is the intersections of these two domains? The way that I'll find it out is if I just draw a timeline, say, this is negative 2, this is negative 1, and let's say this is 3 and this is 5. So we know this one's from negative 2, which is inclusive, to 3. And the other one is from negative 1 out, to 5 inclusive. So what is the point of intersection? The point of intersection is from negative 1, not included, x, not included, 3, which is E. Next question, 4. Consider the simultaneous linear equation below containing the parameter k. These two are here. The values of k for which the system of equation has infinite solutions. Okay, I'm just going to do this on my calculator. What I'm going to do is actually, I'm going to use the determinant, and I'm going to use these matrices. So our k values, our x here, these are your x and these are your y. So your first one is k and 5. The next one is 4, k plus 1. And yeah, so 4k plus 1. And what we're going to do is solve, answer equals 0, comma x. Oh, sorry, comma k. And we get negative 5 and k equals 4. To double check which one has infinite solution, what we have to do is resub it in to both of the equation. If the equation looks similar, both the gradient and the y-intercept, it is a infinite solution. Let's check k equals 4. Let's sub that one in. So for the first equation, it will be 4x plus 5y. So so it'll be 9 here. The other one will be 4x plus 5y, okay, equals 0. No, so if I solve this for y, this will be negative minus 4x over 5. And this one would be negative 4x over 5. No, they are not the same. So negative 4 is not the actual thing. What about negative 5? So negative 5x plus 5y, 0, 4x. So if I put negative 5, so 1 minus, so it'll be negative 4y equals 0. If I solve for y for this one, it will be 5x divided by 5, which is just x. And the other one will be 4x divided by 4, which is again x, yeah. So they have y equals x. So x, k is negative 5 is where, yeah, you will have infinite solution. So choose B. Yeah, so k is equal to negative 5. Perfect. Which of the following functions has a horizontal tangent at this? What I'm going to do is just graph them pretty much. I'm not going to, just to make laziness, just to graph them. So negative 1/3, we get this. Now, of course, there's actually no horizontal, like at 0, there's actually no point. So that's useless. The next one is, this is a positive, and you get this. So if I draw a tangent, it will look like pretty much, it doesn't exist. There isn't an actual. The way that I would do is menu, geometry, points of line, tangent, and if I put a tangent over here, it's vertical. It's pretty much a vertical, so no. The next one is 2/3, so 2/3, and we get this. Again, if I draw a tangent, what happens is it's not a horizontal, so absolutely not that one. Next one is 4/3. So if I put a 4 here, we get this. So let's double check. Geometry, points of line, tangent. Aha! It is a horizontal tangent. So yes, x equals that. So D should be answer for that. Question 6. Suppose that from 3 to 10 is that, 7 to 10 is that, and the value of 7 to 3 of f of x is what? Okay. What I like to do for these questions is kind of just draw it like a graph, a fake graph. So I know from, let's say this is 3 and this is 10, is C. And I also know that from 7, let's say 7 is this number here, from 7 to 10 is D. Okay, then what's 7 to 3? So I'm just going to find out first what's 3 to 7 of f of x dx. So 3 to 7. Let's call it x. So it'll be x plus, if we add it with the 7 to 10, which is D, should equal 3 to 10, which is C. So we solve for x, so C minus D. And remember, because we're going to have to flip those to get from 7 to 3 for our answer, we will have to do, minus here. So it will be D minus C. So choose 6D as your answer. Yeah, so 6D. Let f of x be this, where x is greater than 0, and g of x be this, where x is less than 1. The domain of the derivative of this is what? So what I would do is, let's just define them on our calculator. So let's control N this. So f of x is natural log of x. G of x is square root of 1 minus. Luckily, we don't have to deal with the domains because the domains are the implied domains or the actual maximal domains. So the domain of the derivative, what's f of g of x? We get this equation. So, okay, and let's find the derivative of it. And we get this, and we can actually, like domain of this answer, comma x. And we get x is all rules with the exception of 1, which is not one of our solutions. Okay, let's extend y. So if I just graph this without its, just have a graph of this. If I just graph this, which is this, yep, so 1 to negative infinity, that's your derivative. So that's your actual f g of x. And so our derivative one was this, which is that. Aha! If you have a really look at this. Now, of course, the positive of this one is useless. So we're only taking from negative infinity to 1 not included because there's an asymptote at this value. So we're saying from negative infinity to this point, which is 1. And 1 should not include it. So negative infinity to 1. Is that right? The domain of the derivative of f of g. So, well, it cannot be all reals. It cannot be from 0 to 1, 0 to infinity. It's only be b or c. But, yeah, 1 looks like the... C looks like the best because 1 is not included because if you have a look at f2 of x, it's an actual asymptote. So, yeah. So choose 7C. I hope that's right. So 7C. 7C. Okay. A box contains n green balls and m red balls. A ball is selected at random and the color is noted. The ball is then replaced. Okay, replace means binomial. In 8 such selections where n is not equal to m, what is the probability that a green ball is selected at least once? So at least once. And we can write that as the 1 minus the probability of x equals 0. And let's say x is binomially where the so there's 8 selections, and there's also what is the probability of getting a green ball, which is just n over the addition of both of them, so n plus m. We get, okay, so what's the probability, so what's actually probability of x equals 0, which is just n, which 8 choose 0, n plus m, 0, m plus n plus m, 8. These become 1, which is just m plus m, 8. And then we're going to 1 minus that. So that should give us C. Is that right? 1 minus m plus m. Okay, that looks good. Oops. Come on. All right. Let's go up. The function f is given by this. Okay, the value of a for which f is continuous and smooth at x equals 2 pi is what? Again, I'm just going to graph it. Make my life easier. So, let's just draw tan of x over 2 from 4 root x with 2 pi, that. And we also need to draw sine a times x, given that from 2 pi, oopsie, 2 pi root x to root 8, so to 8. Let me get this. Okay, so the way that I'll check is just, I want to zoom in inside here. Let's just, because we have 5 values of a, let's just sub them in and see which one looks the most smoothest. Or maybe sometimes, yeah, they could trick you, but let's just check. So a equals -2. Rubbish, that's a broken. Nope. Negative pi on 2, so let me just put pi on 2. Nope, they are discontinued. So what about the next one, which is -0.5? Aha, look how beautiful this one is. This one looks right. What about the next one? So C looks right. What about 0.5? No, it's broke. It's very, yeah, 2. Okay, this one's rubbish too. So the most best answer for question 9 would be C. Yeah, so do that. Perfect. And you can, let's actually double check it. The way I would double check it is, okay, so if I go to, for example, so let's say a equals 2, and let's go on this. So if I can find the gradient of, which one's the tan? So f1 of x, it's this. And if I take this and actually sub in x equals 2 pi, so it's equal to a half. Okay, that's the gradient. Let's double check it for the other one. f2 of x equals this. And let's say when x is equal to 2 pi. What have I done? Wait. Have I made a mistake here? Oh, no. We said, oh, sorry. This was supposed to be -0.5. We chose C, yes. -0. Let's try them now. What happened, man? Okay, so yep, that's a half. That's all right. But this one gets changed. So this one, this, and we get this, given that x is equal to 2 pi. Okay, half. So both have the same gradient. Yes, this one is. So question 9 is the C is your answer. Question 10. A continuous random variable has the following probability density function. The value of k is such that probability that x is less than k is 0.35 as well. So what I'm going to do is for this question is I'm just going to find the integral for the first one. So we know that from 1 to 6, what's the actual area that it's taking? So x minus 1 over 20 dx, which is 5.8, which is approximately 0.625. Yes, we're trying to find the probability that some value is less than, is 0.35. So it's around this over here. So what I would do is I would change this to k and let this equal to 0.35. Yep. And I will solve answer, comma, k. And we need k to be greater than 0 as, So it's 1 plus, or root 14 plus 1. So question 10 is B. So question 11. Two functions f and g are continuous and differentiable for all x's and all reals. It is given that f of -2 is this, and g of -2 is 8, and f dash of -2 is this, and g dash of -2 is 2. The gradient of the graph of f of x and g of x at the point where x is equal to -2. Okay, just let's understand this. I'm not understanding. So let's say that f of -2, which is, so this is -2. So f of -2 is -7. So this, let's call this blue graph f. And that's that. Now the yellow one is g. And at -2, oops. So and at -2, it's 8. So it would be over here. And we know that the gradient of f dash at -2 is 3. So it's like a slope up. And at -2 for g, it's kind of a slope, a little bit. It's much dimmer for this one. So it's like around here. Then what's the gradient of f of x times g of x? Okay. Luckily, they've given us so much information that we can just make 2 equations for both of them and just kind of do this and then sub in what's the gradient of x equals -2. I have no idea what to do with this, so that's what I'm going to do here. So, to do that, let's look at f. Let's make an equation from f. So, we can say that y, this is for f, the tangent at f, so y plus 7 equals 3x plus 2, so y equals 3x plus 6 minus 7, y equals 3x minus 1. Is that true? Yes, so you should pass around -1 here. That's a beautiful equation that we can use. What about the next one? Same thing. So y minus 8 is equal to 2x plus 2, y equals 2x plus 4 plus 8, y is therefore 2x plus 12. So we have these 2 equations, and yeah, let's multiply them together and find the gradient of that. So if I multiply these 2 equations, which is just 3x minus 1 times 2x plus 12, I'm going to find the gradient now of this equation. Yep, and I want to sub in x equals -2. 10. 10 should be your answer. So choose 11E. Question 12. The probability mass function for the discrete random variable is this. The maximum possible values for the mean of this is what? Okay, what I would do is first add them and see if they equal, and we let them equal 1 and find the value of k. So we're saying k squared plus 4k, if you add those two, minus -x squared minus 4k plus 1. Ah, it just equals 1. Wow, so that's no use. So let's actually find the actual mean. So to find the mean, it's just negative, okay, we have to find the mean formula. It's -1 times k squared plus k plus 2 times negative k squared minus 4k plus 1. And we get this. So this is your mean. And what we're going to do with this mean is we want to find the maximum possible value. So what I'll do is I'll just go menu, calculus, maximum for this, comma k, given that k can only be between 0 to 1 because it's probability. So at k equals 0 is your maximum. So bring this over here, the mean. So your mean value should be, the maximum possible value for the mean is 2. So choose E. Okay, wow, pseudocode. The following algorithm applies Newton's method using a for loop with 3 iterations. So f of x is that, df of x is that, x naught is that. Define this. Okay, this is the beautiful Newton's method from 1 to 3. And yeah, so what I'm going to do first is we need to find the return value, so this value over here, of the function Newton blah 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 this. Okay, so I'm going to, because we're doing 3 iterations, I'm going to, so this is your first, this is your second, and this is your third. And okay, so we know that x naught is here is 1, as it's shown here. Yes, x naught is 1. So yeah, so x naught is 1. And yeah, let's use the formula. So for I, yes, blah blah blah. If dx, well, x naught is actually 1, so it shouldn't equal. So if I subbed in 1, it will be -3, so it's not actually not. So we can move on to this else. So we can just say this is x1. x1 here is equal to x naught, which is 1, minus f of 1 over f dash of 1. Let's find out. That's going to give you this one over here. So let's define f of x as the function x to the power 3 plus 3x Is that a minus? Okay, what's that? That's a -3, yeah. So we get this defined function. So we've defined it, and what we're going to do is, okay, so we want to find first what's f of 1. Yep. We also want to find f dash of x, which is this. I've already given it to us, but when x is equal to 1. So we've got this, so it'll be 1 minus this over here divided by this over here, which is 6. And this gives us your new x1, so which is 516. So let's write that down, 516. Using the same formula again. Now, if I sub in 516, it shouldn't actually, so what's f of, let's check. F of 516, does that give me letter equal to 0? No, it's not equal to 0, so we can move on to the outs again. So, okay, so it tells us that your new value, so 516, which is this one over here, minus, so wait, let's actually first find, this is your derivative of 516. We get this, so it will be 1 minus, okay, this over here goes here, and this over here goes here. And this gives you this value over here, which is your x2, which is your third iteration. This is the answer. Oh, no. Wow, what the hell? Absolutely, this is not the answer, because it's not part of the answer. What have I done here? So, we've done that. And we've subbed that into the derivative, which got 61 over 25. So, and we said 1 minus... Oh, what? Wait. Oh, no. We have made a big mistake. A very stupid mistake. Yes. Dumb mistake. So, okay, what we've done is so stupid. So, just be careful. Our x naught changes. I did not think about that. So, what I'm going to have to do is, okay, 516 is true. So, we just have to use this over here, but put here 516 to fix it. Is that not mistaken? Yeah. Yes, that was it. That was the mistake. Sorry guys if I'm going too quick. I just want to pull out the solutions for some students. Yeah, so if I'm not mistaken, 13 would be B. Question 13 would be B. That's your third iteration, and that would give you your return value. 81785. Yeah, let's move on. I hope that's right. Yeah. Question 14. A polynomial has the equation this, a number of tangents to this curve that passes through the positive x-intercept is what? So let's just have a sketch of this. X times 3x minus 1. Oops. So this is best way. 3 times x plus 3. X plus 1. So we get this. And we want the number of tangents to this curve that passes through the positive x-intercept. So this positive x-intercept was only 1. At x equals 0, by the way, is not a positive, so it's this one only. So yeah, we can just find the tangent at, find the gradient at this point here. Wait. So if I can, hey, what's happening with me? So if I find the gradient, yes, at x, this value here. Wait, what's happening to me? A polynomial has the equation y equals this. The number of tangents to this curve that pass through the positive x-intercept is what? So, also have one here. We can also have one that could pass through here. So what I would do here is, wow, I don't know what's happening with me. Okay, so what I would do is, what's this point? Just by looking at the equation, it's 1 on 3. This is 1 on 3 here. So what I would do is, okay, we just find the derivative of f1 of x. So f1 of x, that. And we want to find the gradient where x is equal to 1 over 3. And it's equal to 40 over 9. Now, we can take this and actually just solve for this. Is that right? Solve, answer, comma, x. So it gives us two values. It gives us two values that could also be, tangents. So I want to double check. So menu, calculus, don't want to, f1 of x, comma, let's chop this point in. We get this, so let's sub that in. All right, this is, So, the number of tangents, that doesn't work. What do we do? Well, okay, let's visualize it. Let's start visualizing things. Okay, so what I would do now, because I have no idea what I'm doing, is just go menu and again, geometry, and go and point tangent and see what's going to happen. So as I go through this tangent, we can see that there is a possible way that around one point over here, it will, can you see the arrows? It will go through this. So there could be one here. There's one tangent. What about if we pass? So that will be one tangent. There could also be a tangent somewhere over here. That could also pass. So that will be a 2 here. Well, could it actually? So that will be 1. Itself is a second. We also have another one here, 3. Could also pass through that tab. 3. There's nothing going to pass through here. Nothing. And somewhere around here, it should pass around here. So 4. And here, there is no way it's going to reach. So, okay, just let's double check it. So if I put it... Ooh, what's happening? Okay, so if I put it around here, this tangent, it's gonna pass. One's gonna pass here, and if I take this, so yep, I'm gonna pass through here. So that'll be 1. Wait, so that'll be 1. That will pass here. They will. Oh my god. The number of tangents that will pass this is what? Why is it so? I don't know what's happening with me. Okay. So, okay, wait, let's choose on that. 1 here. Absolutely 1 will come here. 1, yes. Which will be the 1, yeah, so 1. Go up here. 2. Around here is 2. And there will be 3 here. Yes. It can only be 3. And the third one will occur here. That will 3. And here it won't happen. Nothing will happen. So 3. Again, 3, yes. So if I go down, there'll be 1 passing through it. This over here will be the same. So yeah, 1. There'll be a 2 here. And there should be a 3rd here. So question 14D, if I'm not mistaken. That's, yeah. Oops. Ooh, what happened? Okay. What just happened here? Let's go. All right. So, okay. Question 14, I would suggest it's D as your answer. Choose that. Yeah, just looks like the most. Yeah, question 14D. Next question. All right. Question 15, let x be a normal random variable with a mean of 100 and standard deviation 20. Let y be the random variable with a mean of 80 and standard deviation 10. Which of the following below will represent the probability density function for x and y? Okay, I've seen this kind of question before. So, x is this one and y is this one. So, what do we know? Well, we know that because the standard deviation of x is much higher, it means its spread will be higher. Look at this one, how it's spread, like how it's spread. So x here will likely be that one. Here it's also spread. No. Here they're saying they both have the same spread. Here they're saying that y has a much more spread. No. And here again they're saying y would have much more of a spread. Also, we also know that the mean is greater for x. So what does that mean? It means this is your mean here. This is your, let's call it x1, and this one here is x2. Yes, we know that the mean of x is greater, so yeah, choose A. That was easy. So let x be f of, wait, did I skip? Oh yeah, let f of x be this, given that the product rule of this is that, find the rule of g. Okay, easy. I need to go quick because I think I took too long with that question. So let's just say g of x well, let's actually define f of x. So f of x would be e x minus 1. Oh, x minus 1 actually. 1, and let's just give the first one, g of x, as the first, which is this over here. So yep, so let's choose a first, and if we multiply them, they should give us the product. It should say true. The calculator should say true if they are equal to this over here. Nope, they are not equal. So, well, let's check the next g. So g for the next one would be just x minus 2. And let's try that. Let's put this again. True. So yes, choose 16B. 16B. Question 17. A cylinder of a height h and a radius is formed from a thin rectangular sheet of metal with the length x and the width b by cutting along the dashed line shown. Okay, so the volume of cylinder in terms of x and y. Okay, so when you're drawing a cylinder, it looks like this. So this over here is this over here. This thing. And we know the volume of a cylinder is what? Pi r squared h, if I'm not mistaken, yeah. So this is your height and this is your radius. So I know for a fact that the volume is pi. Your radius, think of it like as this becomes, your radius is just r squared. Your h is the height, and we know that this here is 2r, and this is 2r, so x minus 4r to get this. So x is minus 4r for that one. So we can say x minus 4r, and we want it in x and y. So, okay, we also know that if this here is y, this over here, when the thing gets rolled, this length, so at the actual y length, should equal the circumference of this circle. So y equals 2 pi r. So if I rearrange it to get r, it's y equals 2 pi. So if I sub that in, so volume is equal to pi, y equals 2 pi squared, x minus 4, y equals 2 pi squared. No, just, yeah. That, yeah, let's put that in our calculator and see which one it would simplify to. Okay, let's do that. Pi times y 2 pi squared x minus 4 times y 2 pi. And so we get this. So this one, if I kind of expand it, okay, just keep this actually. So if I multiply that, that's negative 2y to the power 3. Which one has that? It looks like this only, B looks like the answer because B has negative 2y. Yep. Let's double check if it has everything. So 4 pi squared. And if I multiply that, yes, B is the answer, hopefully. Question 18, consider the function this, f of x is that, where a is a positive integer. So positive integer. The number of local minimum in the graph of f of x is always equal to 1. So let's graph it. You know, graphing is always going to help you with these kind of questions. So sine a times x. All right. From the domain negative a pi through x to a pi. So this over here. And we get this. So we know that when a is equal to 1. So what happens? Wait, what's the local minimum when a is equal to 1? It's 1. 2, 1, 2, 3, 4. 4 when a equals to 2. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So, okay, so wait. So we're saying that when a is equal to 1, there was 1 minimum value. When a equals to 2, there's 4 minimum values. When a equals 3, there is 9 minimum values. What about when a equals 4? Wait, let me guess, 16. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8. And this should be reflected, so 8 plus 8, 16. So they're just going, so the middle number is not an actual number. It's, if it's saying 2a, 2 times a, nope. So e, yeah, was like, you know, a, like here is 1 squared is 1, 2 squared is 4, 3 squared is 9. Yeah, so 18e. Question 19, find the values of k such that the equation this has two real solutions for x, one positive and one negative. Okay, we're given all these values of k. Easy. Just graph it. So we're saying x squared plus 4k plus 3 times x plus 4k squared minus 9 over 4. Is that right? Let's double check if okay, this there. Okay, we got this. Okay, the first k values we're saying is where k is greater than negative 3 over 4. So let's double check that. So if I said negative 3 over 4, and we're saying k is greater than that, we should get one positive and one negative x-axis. So, okay, that's good. Go higher, because we're saying from to infinity. No, so we get two negatives then. So that's not right. Also, B is not right. It's just the same thing. C, K is what? Well, now we're saying 3 over 4. So 3 over 4. And we go to infinity. Again, still we get two negatives, so that's not right. What about D? We're saying from negative 3 over 4. 3 over 4. Let's double check that. All right, so it's still, we have two, one negative, one positive. And yes, this looks like the best. Whereas E is wrong, because K is greater than 3 or 4, we still get no. So D would be the best answer for that one. 20, let f of x be this, g of x be that, where x is an element from negative infinity to 5. The largest interval of x, for which f of g of x and g f of x both exist, is what? Look, I'm not going to lie. This is going to be hard, because if you're going to do the algebra way, like, you know, I think like the domain, where the range of G must be the subset of domain, and then you have, yeah. What I'm going to do, just going to think, wait, f of x is that, g of x is that. The largest interval for which g of x and g f of x both exist as well. Okay, let's do this. Control N, let's just define them in our calculator first. So, oh wow, so f of x is the natural log of x plus 1 root 2, and g of x is sine x, where it's from negative infinity to 5. So if I was saying f of g of x, which is this equation, let's graph that, which is this, because the g of x is inside, it's normally the domain of g of x that is the important one. So because we know the domain of g of x is negative infinity to 5, we can just say, I think, from negative infinity to 5, that, and we also want g f of x. So g f of x. Yeah, so if we draw g of x here, so when it's the larger possible for which both of these exist, I think these values. So, okay, have a look at this. Well, this one goes forever. No, we want only when it's restricted along here. So it's, for the answers are saying 5 pi on 4. So if I just say, go on menu, is that true? Entry relation, x equals 5 pi over 4. Oh, sorry. So 5 pi over 5 pi. Oosh, what have I done? Okay. 5 pi over 4. Okay, yes, perfect. So we can see that 5 pi over is an asymptote. So we shouldn't even include it. So which ones don't include 5 pi over 4? D and E, that we can restrict those, take them out. Well, let's look at C. It's also saying from negative pi over 4. So if I draw where x is equal to negative pi over 4. Okay, wow. So that is the asymptote. But the problem is it's not including this g f of x. As you can see, it's actually not in that thing. So, wait. Wait, oh my god, this is an actual hard question. Well, okay, we know it's not D or E. Could it, and, so we get negative 5 pi, so negative pi over 4. It's this, it's because it says the larger interval for x. Okay. Wow. This is actually a hard question. I don't actually 100% sure would get this one. So I'm just gonna think about it. Okay, so we have this beautiful thing here, and we have this that's, and we got this that goes like that, and it's not touching. If we are including, okay, let's actually just, okay, what about if we said, well, the other ones just say negative 1 over root 2. Let's put that. So if we put negative 1 over root 2, it touches it. But then it goes over this problematically, yeah. So if I was, negative 1 over root 2, what does it want, negative pi? So if negative pi over 4, it's included in these, and yeah, I think it could be, look, it could be, I don't know if it sees wrong, that's the problem. I know it's 5 pi over 4, and the end one's is 5 pi over 4. Because it includes that, and it could include that. Whereas this one, okay, yes, okay. Negative 1 over root 2, it should be, because it's touching that. So if it's touching that, and it's also, wherever it's crossing this, so it should be restricted also, yeah. So negative 1 over root 2, okay, so C is wrong, so it could only be A on B. But we need to remember that we cannot have negative 1 over root 2 included, because having a look at this, the actual solving this, negative 1 over root 2, it's an actual asymptote in the actual f of x, and it shouldn't actually be included. But yeah, that's what I think, so it should be A. Yeah, 20A. All right, I hope you guys can, look at these solutions and, see if you, try to check your answers. Yeah, thank you guys for watching. I will hopefully, go for the extended response when I have time. I'm quite busy today, but yeah, I hope you guys enjoy this video, and please make sure to like and subscribe for more of these videos. Good luck, year 12s who's finished methods right now. Good luck with your future. I know methods was a pain in the ass, like always, but yeah, good luck with, your future and your future studies. Have a good day. Bye-bye.